Ever feel like reality is just off? Like someone swapped the laws of physics for a cosmic magic show? Welcome to Curiosity Corner. Today we're diving headfirst into the mind-bending world of quantum mechanics. Here, in the quantum circus, the usual rules go out the window. Things pop in and out of existence, sometimes they're waves, sometimes they're particles, and observation itself becomes a superpower. Intrigued? Good, because today's main event is a doozy quantum disorder. Get ready to discover how reality changes depending on who's looking. Now in our everyday world, we're used to things being one way or the other, orderly, like a perfectly stacked tower of blocks, or chaotic, like a room after a hurricane of toys has blown through it. But in the quantum realm, things get a little blurry. Imagine trying to pin down a cloud or describe the exact location of a dream. That's quantum disorder, slippery, unpredictable, and always keeping you guessing. It's like the universe can't quite make up its mind, flitting between order and chaos on a whim. And the kicker? We might actually have something to do with it. You see, in this quantum circus, observation isn't just about watching the show, it's about influencing the performance itself. Think of it like this. Imagine a cosmic spotlight shining down. Wherever that spotlight lands, reality snaps into focus. But what about everything else lurking in the shadows? That's where things get really interesting. Because in the quantum world, the act of observing might actually be what tips the scales between order and chaos. So, are you ready to explore how our very presence might be shaping the fabric of reality? Then hold on tight because things are about to get very, very strange. Imagine a world where everything has its place. A world where planets waltz in perfect orbits, atoms line up like obedient soldiers, and your morning coffee never gets cold. That's the comforting predictability of order. It's the satisfying click of a puzzle piece slotting into place, the rhythmic tick-tock of a perfectly calibrated clock. Order is the backbone of our everyday experience, the reassuring rhythm that keeps the universe from dissolving into utter chaos. But here's the thing about order. It craves control. It thrives on predictability, on knowing exactly what's going to happen next. And for a long time, that's how we thought the universe worked, like a giant, finely tuned machine, ticking away with predictable precision. But what happens when we peek behind the curtain, into the hidden workings of reality itself? That's where things get a little messier, and a whole lot more interesting. Let's start with something simple. A line of dominoes poised to topple. One nudge and a chain reaction unfolds, each domino faithfully knocking down the next. That's classical order in action, predictable cause and effect. It's the same principle that governs everything from the graceful arc of a ball thrown through the air to the intricate dance of planets around a star. Order loves a pattern, a reliable sequence we can set our watches to. And for centuries, that's how we understood the universe, as a grand orderly machine, governed by immutable laws and predictable outcomes. But then, along came quantum mechanics. And suddenly, the universe decided to throw a cosmic curveball. Because it turns out the universe has a mischievous side, a love for the unexpected that throws our neat and tidy assumptions into disarray. Now let's talk about chaos. Not the kind that sends shivers down your spine, but the kind that makes life interesting. The kind that whispers, "Expect the unexpected," and then throws a pie in your face just to prove a point. Chaos is the wild card. The unpredictable dance of 1,000 butterflies whose wings just might trigger a hurricane on the other side of the world. It's the exhilarating feeling of riding a roller coaster, never quite sure which twist or turn awaits you next. Chaos is the universe reminding us that it's not always about following the rules. Sometimes, it's about breaking them in spectacular fashion. And in the quantum realm, chaos isn't just a possibility, it's the name of the game. Now, here's where things get really wild. In the quantum world, the line between order and chaos gets, well, a little fuzzy. It's like the universe looked at our neat categories and said, nah, I'm gonna need a bigger box. Imagine a world where things can be in multiple states at once, both a particle and a wave here and there, up and down. It's enough to make your head spin. It's like trying to nail jelly to a wall. Just when you think you've got a handle on it, it slips through your fingers and changes form right before your eyes. And the craziest part? We might actually be the ones responsible for this quantum quirkiness. Buckle up, because things are about to get even weirder. You see, in this quantum circus, observation isn't just about passively watching the show, it's about actively participating in it. It's like the universe is waiting for us, the audience, to choose our own adventure. And the choices we make simply by observing might be the very thing that tips the scales between order and chaos. Sound impossible? Well, get ready to have your mind blown, because in the next act, we're diving headfirst into the mind-bending world of quantum experiments and the observer effect. Alright folks, time to buckle up and prepare for a wild ride because we're venturing into the mind-bending world of quantum mechanics. Imagine a place where the usual rules of reality go on vacation, and things get downright bizarre. Down here, at the subatomic level, particles can be in multiple states at once, teleport through walls like ghosts, and even communicate faster than the speed of light. It's enough to make your head spin. Quantum mechanics, you see, is like the rebellious teenager of physics. While classical physics plays by the rules, quantum mechanics throws the rulebook out the window and says, "Hold my beer and watch this." And trust me folks, the tricks quantum mechanics has up its sleeve will leave you questioning everything you thought you knew about reality. So, are you ready to meet the ultimate rule breaker? Let's dive in. Now, to understand just how strange things get in the quantum world, let's talk about one of the most mind-boggling experiments ever conducted, the double-slit experiment. Picture this. Scientists shine a beam of light through two tiny slits, like a cosmic game of peekaboo. Now, based on our everyday experience, we'd expect to see two bright lines on the screen behind the slits, right? But here's where things get weird. Instead of two lines, the light creates an interference pattern like ripples in a pond. It's as if the light waves are somehow interfering with themselves, even though they should be passing through different slits. How is that even possible, you ask? Well, hold on tight because it gets even weirder. When scientists try to measure which slit each particle of light goes through, the interference pattern disappears, and we're left with just two boring lines. It's like the universe knows we're watching and decides to change its act. The double-slit experiment reveals a fundamental principle of quantum mechanics: uncertainty. Unlike the orderly, predictable world of classical physics, the quantum world is a chaotic dance of possibilities, where nothing is certain until it's observed. You see, in the quantum realm, particles don't exist in a fixed state until they're measured. Instead, they exist in a superposition of all possible states simultaneously, like a cosmic coin spinning in midair, neither heads nor tails, until it lands. This inherent uncertainty, known as Heisenberg's uncertainty principle, means we can never know both the exact position and momentum of a particle at the same time. It's like trying to catch a shadow. The harder you grasp, the more elusive it becomes. So, in a world governed by quantum mechanics, disorder isn't just a possibility, it's the fundamental nature of reality itself. But how does this quantum chaos affect the world we experience every day? Let's find out. Let's find Now here's where things get truly mind-blowing. The act of observing a quantum system, of shining a light on the uncertainty, actually influences the outcome. It's as if the universe is waiting for us to make a choice before it decides what's real. This is the observer effect in action. When we observe a quantum system, we force it to choose one state out of the many possibilities, collapsing the wave function and bringing a specific outcome into reality. It's like the universe is a cosmic choose-your-own-adventure book. And our observations are the turning points in the story, shaping the narrative of reality itself. So, in a very real sense, we're not just passive observers in this grand cosmic play. We're active participants, our very presence shaping the unfolding drama of the quantum world. Now you might be thinking, okay, That's all very fascinating, but how does this quantum weirdness affect me in my everyday life? Well, believe it or not, quantum disorder is everywhere, influencing everything from the smallest atom to the largest black hole. Take photosynthesis, for example. Plants rely on the quantum behavior of photons, the particles of light, to convert sunlight into energy. It's the quantum world that allows life as we know it to flourish. And what about our modern technology? Computers, smartphones, lasers, all these technologies are built on our understanding of quantum mechanics. Without it, our world would look very different indeed. And let's not forget about the mysteries of the universe itself. Black holes, dark matter, the Big Bang, these cosmic enigmas are all deeply intertwined with the bizarre world of quantum mechanics. So while the quantum world may seem strange and counterintuitive, it's not some abstract concept confined to the laboratory. It's the very fabric of reality, woven into the tapestry of existence at every level. And we've only just scratched the surface, folks. Because when we start exploring the implications of quantum disorder on consciousness, on the nature of reality itself, things get really wild. Could our minds, our very consciousness, be influencing the quantum world around us, shaping reality with our thoughts and intentions? It's a question that has puzzled philosophers and scientists for decades, but we'll save those mind-bending explorations for another day. For now, let the implications of quantum disorder sink in, and prepare to see the world around you in a whole new light. Deep down, in the labs where science fiction meets reality, researchers are always cooking up new ways to peek behind the universe's curtain. And one of their favorite tools? Ultra-cold atoms. Now these aren't your average run-of-the-mill atoms. Oh no, these are atoms chilled to within a hair's breadth of absolute zero, the point where almost all motion stops. Why? Because at these incredibly low temperatures, quantum weirdness takes center stage. You see, at these extreme cold temperatures, atoms start behaving less like individual particles and more like a collective wave, their individual identities blurring as they enter a state of quantum coherence. It's like a synchronized swimming team of atoms, all moving in perfect harmony. And it's with these ultra-cold, quantum-synchronized swimmers that scientists have been able to directly observe how the act of observation can influence the very nature of disorder itself. So, picture this. Scientists create a cloud of these ultra-cold atoms, trapping them with lasers in a carefully controlled environment. Think of it like a subatomic corral, where the atoms are free to roam within a confined space. Initially, the atoms are in a state of quantum chaos, their movements and positions governed by the inherent uncertainty of the quantum world. It's a subatomic mosh pit, with no apparent rhyme or reason to their movements. But here comes the mind-blowing part. When the researchers introduce a measuring device, a way to observe the atom's state of disorder, something incredible happens. The act of observation itself influences the atom's behavior. It's like the atoms are camera-shy, suddenly self-conscious about their messy quantum dance floor now that someone's watching. But instead of freezing in place, they adjust their movements, becoming slightly more ordered, their chaos subtly tamed by the act of observation. Now I know what you're thinking. Does this mean we can organize our messy desks just by staring at them really hard? Well, not quite, though wouldn't that be nice? The kind of order we're talking about here is subtle, taking place at the level of atoms and their quantum properties, but the implications are anything but small. You see, this experiment provides direct evidence that the act of observation, of measurement, has a direct and measurable impact on the state of a quantum system. In this case, it's influencing the degree of disorder within a cloud of ultra-cold atoms. It's like discovering that the spotlight in a theater doesn't just illuminate the actors, it somehow influences their performance, their every move subtly guided by the act of being observed. This experiment with ultra-cold atoms opens up a Pandora's box of questions about the nature of reality, of observation, and the very essence of order and chaos. If the act of observation can influence the state of disorder in a quantum system, does that mean we can control chaos itself? Could we harness this power to create new technologies to manipulate the fabric of reality at the most fundamental level? Imagine a world where we could manipulate the quantum world with the same ease we flip a light switch, where the seemingly chaotic dance of particles could be choreographed to our will. The possibilities are as mind-boggling as they are potentially limitless. But one thing's for sure, the quantum world is far stranger, far more wondrous, and far more interconnected with our own existence than we ever imagined. We've journeyed deep into the quantum realm, folks, where things get fuzzy, particles play hooky from the laws of physics, and reality itself seems to have a serious case of the shimmers. But as we delve deeper into this mind-bending world, we're forced to confront a question that's haunted philosophers and physicists for centuries. What is reality really? Is it something objective out there existing independently of us? Or does the very act of observation, of measurement, somehow breathe life into the world around us? Buckle up, folks, because as we explore the observer effect and its implications, we're about to enter a hall of mirrors where the line between observer and observed, between reality and perception, becomes tantalizingly blurred. Now, the observer effect isn't just some philosophical thought experiment dreamed up by physicists with too much time on their hands. Oh no, this is where quantum theory gets real, folks. You see, in the quantum world, particles don't play by the same rules as our everyday objects. They exist in a fuzzy state of potentiality, a superposition of all possible states, until someone decides to take a peek. And that's where the observer effect comes in. The very act of observing, of measuring a quantum system, forces it to choose a definite state, to collapse from a wave of possibilities into a single point of reality. It's as if the universe is saying, hey, you want to know what's really going on? Fine, but you're going to have to make a choice, because I'm not showing my hand until you do. Now, to understand the mind-boggling implications of the observer effect, we need to talk about one of the quantum world's biggest celebrities, the electron. You see, electrons, like all quantum citizens, are notorious multitaskers. They can act like particles, tiny points of matter with a definite location, but they can also act like waves, their energy spread out over space and time. So, which is it, a wave or a particle? Well, that's the million-dollar question, folks. And the answer, as you might have guessed, is, it depends. And what does it depend on? You guessed it, whether anyone's watching. Now, to really see the observer effect in action, we need to revisit our old friend, the double-slit experiment. Remember how those mischievous photons were creating interference patterns, acting like waves even though they should have been acting like particles? Well, electrons pull the same trick. But here's where things get really interesting. If we try to sneak a peek, to measure which slit each electron goes through, the interference pattern vanishes. It's as if the electrons, those masters of disguise, know they're being watched and decide to ditch their wave-like costumes, snapping back into their particle identities. It's enough to make you question the very nature of reality itself. The observer effect throws a real wrench into our classical understanding of reality. It suggests that the universe, at its most fundamental level, is not a collection of independent objects but a dynamic dance of possibilities, shaped by the very act of observation. But here's the even bigger question. If observation influences reality, then whose observation matters? Does a dog collapse the wave function when it sees a squirrel? Does a tree observe the setting sun? And what about consciousness? Does our awareness, our very thoughts and intentions, play a role in shaping the quantum world around us? These are questions that science is only just beginning to grapple with. But one thing's for sure, the quantum world is stranger, more wondrous, and far more interconnected with our own existence than we ever imagined. We've seen how observation can make reality snap into focus, how electrons seem to know when they're being watched, but what about the ultimate mystery, consciousness? Could our minds, those swirling vortexes of thoughts, emotions, and that lingering memory of what we had for breakfast, actually be influencing the quantum world around us? It's a question that has tantalized philosophers and scientists for centuries, sparking debates hotter than a supernova. Some say it's all in our heads, that consciousness is just a side effect of a complex brain doing its thing. But others, well, they see something more profound at play, a connection between mind and matter that runs deeper than we ever imagined. Think of it this way. What if we're not just passive observers in this cosmic play, but active participants, our thoughts and intentions shaping the very fabric of reality itself? Imagine a world where our collective beliefs, our hopes and fears, could influence the unfolding of events, where our shared dreams could literally shape the world around us. It might sound like science fiction, but in the quantum realm, where particles can be in multiple states at once, where observation itself can influence outcomes, the line between science and imagination starts to get a little blurry. And who knows? Maybe, just maybe, we're all contributing to a grand collective reality, a shared tapestry woven from the threads of our thoughts, dreams, and observations. Now, I'm not saying you can just wish for $1 million and expect it to materialize out of thin air. The quantum world is a little more subtle than that. But what if our thoughts, our intentions, create subtle ripples in the quantum field, influencing the probabilities of events, nudging the universe in a particular direction? Think about the placebo effect, where our beliefs about a treatment can have a real measurable impact on our health, or the power of prayer, of sending positive energy out into the world. These phenomena might not be easily explained by classical physics, but in a world governed by quantum mechanics, where consciousness and observation play a role, they suddenly seem a little less mysterious, a little more connected to the underlying fabric of reality. We're just beginning to scratch the surface of the quantum world, folks, and the implications of what we're discovering are as profound as they are mind-boggling. But one thing's for sure, the more we learn about the quantum world, the more we realize how much we don't know, and that's what makes this journey so exhilarating. So keep asking questions, folks. Keep exploring. Keep your minds open to the possibilities, however strange or wonderful they may seem, because in the quantum circus of reality, the greatest show is just beginning. We've journeyed far, my friends, from the familiar comfort of classical physics to the mind-bending frontier of the quantum world. We've seen how reality shimmers and shifts, how particles dance to the tune of uncertainty, and how our very act of observation might be weaving the tapestry of existence. It's enough to make your head spin faster than an electron in a particle accelerator. But here's the thing about the quantum world. It doesn't offer easy answers. It doesn't fit neatly into our preconceived notions of how things should be. And that, my friends, is its greatest gift. Because in the face of the unknown, in the exhilarating embrace of uncertainty, we rediscover the true spirit of scientific inquiry, the insatiable thirst for knowledge that drives us to explore the furthest reaches of our universe, and ourselves. The quantum world reminds us that reality is not a static, unchanging thing, but a dynamic, ever-evolving dance of possibilities, a cosmic symphony conducted by the very act of observation. So what does it all mean, this quantum revolution? What are we to make of a world where particles can be in two places at once, where observation shapes reality, and where the very act of looking might be the ultimate creative act? Well, the beauty of it is, my friends, there's no single answer. Just as each of us observes the world through our own unique lens, shaped by our experiences, beliefs, and that lingering craving for pizza on a Friday night, so too might our understanding of reality be as individual as our DNA. The quantum world doesn't demand conformity, it celebrates diversity. It throws open the doors of perception and invites us to explore the infinite possibilities that exist within the realm of the very, very small. So embrace the mystery, my friends, revel in the unknown. Because in the quantum world, just like in life, the journey is the destination, and the more we learn, the more we realize how much there's still left to discover. For decades, the strange world of quantum mechanics was confined to the realm of theoretical physics, a playground for equations and thought experiments. But now, folks, the quantum revolution is spilling out of the labs and into our everyday lives. Quantum computers, those mind-boggling machines that harness the power of superposition and entanglement, are no longer a figment of science fiction. They're here, and they're poised to revolutionize everything from medicine and material science to artificial intelligence and our understanding of the universe itself. Imagine a world where diseases are diagnosed and treated at the molecular level, where new materials with seemingly impossible properties are created with atomic precision, where artificial intelligence transcends its current limitations and achieves a level of sophistication that rivals our own. This is the promise of quantum technology, my friends. A future where the boundaries of what's possible are redrawn, and the seemingly impossible becomes not just conceivable, but inevitable. But with great power comes great responsibility, as the saying goes. As we delve deeper into the quantum realm, as we learn to harness its power for our own purposes, we must tread carefully. For in a world where observation shapes reality, where the very act of looking can influence outcomes, the question of who controls the quantum realm takes on profound significance. We must ensure that these powerful tools are used for the betterment of humanity, not for harm. We must engage in open and honest conversations about the ethical implications of quantum technology, about who benefits and who might be left behind. The future is not predetermined, my friends. It's a quantum superposition of possibilities waiting for us, the observers, to collapse the wave function and choose our path. Let's choose wisely. So there you have it, folks. A glimpse into the weird, wonderful, and utterly mind-bending world of quantum mechanics. We've explored the nature of reality, the power of observation, and the potential of quantum technology to reshape our world. But more importantly, we've been reminded of the importance of curiosity, of questioning our assumptions, and of embracing the unknown with a sense of wonder and excitement. So, keep asking questions, my friends, keep exploring. Keep your minds open to the possibilities, however strange or wonderful they may seem. Because in the quantum circus of reality, the greatest show is always just beginning. Until next time, stay curious.